Today I'm going to talk about Terraform and Terraform most important usage and some other features of Terraform. This video will help you to get to know how Terraform works and how we can use it. Before we talk about Terraform, we should talk about cloud resource provisioning. There are three approaches how we can provision resources on the cloud. The first one is, which is mostly used also, is GUI, graphical user interface. So it's the kind we go to the website of the cloud provider and we use the website of the cloud provider to manage our resources on the cloud. There's also another way to do this is using CLI. So they have modules we have to install this on PowerShell or Bash in Linux. And we can use these CLIs or APIs to manage our resources. But nowadays will be used is infrastructure as code, and this is the most used form of provisioning resources in the cloud is. So in the infrastructure as code, we define our desired state of resources, provisioning it. So, and we use this configuration file through different kind of technologies, and we apply it to many different cloud providers. So we use one file or one configuration with a little bit difference for many different cloud providers. The infrastructure as cloud provider gives also other advantages. They are like it's simple and fast, and it's repeatable. So we write once a configuration, we can use it many times, and it's also used for larger infrastructure to deploy it. So infrastructure as a code had also different categories, or it could be happen or done through different methods. One of them is like ad hoc scripts. That is the kind like we use a CLI or PowerShell or Bash, and we give directly the commands there and we interact with our resources. So it will happen directly. The another method is like configuration management tools, Ansible. So in this method, we also make a configuration file, and in this configuration file, we wrote all our configurations, and we use this Ansible to deploy the configuration on the servers. And there's another method which will also from HashiCorp. The software is Packer. So server templating is kind like we have a server, and on the server is our application is also installed. Let's take like a Linux machine, which is software is also an application you build and you install software on that Linux machine. So and you make with the Packer, you create an image of that machine, and you can deploy this image on many different cloud providers. There's another tool for orchestration tools like Kubernetes. We use that to orchestrate our containerized applications, and we have Terraform for provisioning resources on the cloud. And there is two important things that we have to know before we deploy or we use infrastructure as cloud, which is declarative and imperative. So the declarative is kind like we use a configuration file, and this configuration file we say all the stuff which we need. And on the imperative method is like we use the commands on the we use kind of SSH terminal. We can open it to the server and we use directly give the commands, and we run the commands, so it will change the configuration of the resources. The advantage of declarative is automation, and it's easy to understand and to manage the resources. But imperative is has better performance because you give the codes and commands directly on the command CLI, and then and it will run directly. So for the provisioning to the resources on the cloud, we have different kind of provisioning tools. Some of them are cloud specific, which is like Azure Resource Manager and Cloud, Google Cloud APIs, and they will only work for a specific purpose. Like we use only Azure Resource Manager to interact with our resources on Microsoft Azure, and the Google is also exactly the same, so it will only work for Google. But we have cloud agnostic, and they are we can use it cross cloud for the deployment of resources on the cloud, different kind of clouds with the same configuration. So Terraform and Pulumi is another kind of a Terraform tool. So with the Pulumi and Terraform, you can use one configuration file with a little bit difference to have the same resources on different cloud providers. So we can use for Terraform one configuration file when apply the resources on Amazon, or we can apply it on Google Cloud or Microsoft Azure. But in this tutorial, we are gonna focus on Terraform. So Terraform is an open source tool for building, changing, and versioning your infrastructure safely and efficiently. If you are into infrastructure as code, DevOps, or cloud administrator, this video is for you. So, and the good thing is that we write the configuration file once. We have one configuration file, we save it in the local computer, or there's also other ways that we can also, for the versioning, we use Git or GitHubs. Also, there's another tool which is or features is offered through Terraform, which is Terraform Cloud. You can store all your files there, and Terraform Cloud will use this through the CI/CD pipeline, which will be deploy the configuration on the cloud. So the Terraform will take this file from GitHub or Git repository, and this will apply the configurations on the specific cloud provider. So there are common patterns for using Terraform. Terraform can also work alone for the provisioning resources, but we can use it for other stuffs like configuration management. We need another software which is used. Ansible mostly is used nowadays, and if we combine these two, we can get a better result. So the first step will be like provisioning the resources on the cloud, and the second step will be configuring of these resources which is already there. We can configure it with Ansible. So Ansible is best if you want to use already existing resources and configuring them. And there's also another tool which we can combine it with Terraform is Kubernetes. So with Terraform, we create our configuration file, and this configuration file will have the whole configuration that Kubernetes run on that. So we can specify in the configuration file that how many worker nodes we need for Kubernetes and all this and this resource stuffs. So these resources will be created, and then we will use Kubernetes to run our containerized applications on that resources which is provisioned by Terraform. So we have, before we use the Terraform, we should know how the architecture of Terraform is. So Terraform use mostly configuration files, and this configuration file will all the configuration which is used to provision a resources will be written. After this configuration file is used by Terraform, so Terraform will create a state file. So this state file has all information of the resources which will be deployed or already deployed. So and Terraform take this state file so the state file is also the information which is written in the configuration file. So through the provider, so this state file will be deployed on the cloud provider. So in this example, we will use Azure Cloud, and through the provider of the Azure, we can deploy the resources also on the Azure Cloud. So there are a few sequences which will be mostly used for the Terraform, and they are like Terraform init, Terraform plan, Terraform apply, and Terraform destroy. So these will be also used whenever you create config files. So Terraform init is the first step that you have to use it. Terraform init creates the environment for Terraform modules, which are the basic configuration of Terraform. After that, we use Terraform plan. It's only a preview of the desired state of configuration file. It only shows what will be provisioned and how they will look like. So after that, we have Terraform apply, and this will apply the desired state to provision the resources. This desired state will be taken from the configuration file. So we have Terraform destroy, and this is from the name you can see it, that it will delete all the resources which is created through the specific configuration file. We have providers, so Providers is a thing or a configurations or files that Terraform is used to communicate with the cloud providers. There are a lot of providers on registry .terraform.io. You can find them a lot there. So for example, we have Azure provider, Kubernetes provider, AWS provider. Each provider only works with their own specific cloud provider. For this example, we will take Azure RM, which is Azure Resource Manager. This is one of the produced by Microsoft in Terraform. So it's also certified by Microsoft. So we can use this provider to communicate through our Terraform configuration file with Azure Cloud. And the configuration will look like this. We have created a Terraform file, which will be like you can have any name, but the extension is .tf, which is for Terraform, and we specify the exact configuration and provider for each configuration file. So Terraform use backends for storing the data which is used, like configuration files, state files. All these files will be stored on the backend. We have local backends. We store the data on our computers. For example, if a developer or a cloud administrator creates a Terraform file, so this file will be stored on the computer. There are some downside and good advantages of this kind of usage. So one is, it is easy to start with this kind of configuration, with this kind of backend, So here you just install a Terraform and you just start working on a configuration file and you create a state. So this is easy to start, but there are also downside, which is like sensitive information in configuration file will also it will not be like in plain text, like if you have secrets or passwords, they all will be readable by everybody if somebody get the file. And there is no collaboration, so you cannot share your files. Of course you can share your files, but it will be like a copy of this file with somebody else. If you change your files, so it means there's another copy which is not changed. So this is a downside of the local backend. We have a remote backend. It's another kind of backend which is really good for a company which has, if there are many people working on the same file, so will be mostly used remote backend. And there are many people can work on the same time on the same file, and there are many advantages, such as sensitive data will be encrypted, so there is no data that will be needed on everybody. So like if you have secrets or if you have passwords, they will all be encrypted. And collaboration is also of course possible, so if there's one state file and all the developer can access it. This backend could be Terraform Cloud, or we can use also GitHub or GitOps. Automation of course is possible through the CI/CD pipelines. The only thing which is the downside is like they will be a bit complex to configure these stuffs and to use it. So Terraform is easy to use and everybody can use it to start with that. There are very good documentation of using each modules of Terraform and commands. So on the own website of the Terraform, and we can create our own infrastructure as environment, as a code environments to make this and our local machines and to test it with containers. For example, we can test it on our local machines, and if everything's going well, we can deploy it on the cloud. We can use also Terraform with Ansible and Kubernetes to separate each task. Like Ansible will be used for the configuration of the resources which already provisioned by Terraform, and Kubernetes will be used to manage the containers. And of course the collaboration and versioning will be possible through the GitHub and GitLab, or we can use also Terraform Cloud for that. Thank you so much for watching the video. I hope this video helps you a bit in the starting of the working with the Terraform. And of course, please subscribe our channel, and I will see you in the next tutorial.